All right, so we're doing the radians homework, and we're looking at 9 and 10. When in doubt, always sketch a picture, right? They give you this information, but you don't really have any diagrams to look at and to use your visual learning skills. So let's draw circle A on our paper. What do we know about circle A? It's got a radius of 3. And it has a central angle. You draw any central angle. You name it FAD, right? F-A-D. And that measure of the angle, I'm barely going to be able to fit it. 0.7 pi is the radian measure of the angle. All right. Now we have circle B. I'm noticing it has a radius of 6. So it is double the size of circle A. Excuse my circles drawn with a mouse. It has a central angle, XBY. Don't know where these letters came from. They're very random. So its radius is 6, but its central angle measure is also 0.75. So let's compare and contrast these circles. They both have the same central angle measure, so FAD is congruent to XBY because they have the same radian measure, but they have different radii, meaning they are different sized circles. So I've kind of answered both of those questions already. Is FAD congruent to XBY? Since we know that radian measures angles. It measures the opening of an angle. Not a length, not a distance, but the actual angle. So, are the angles congruent? Well, yes, they are, because the radian measures are equal. I'm not going to write it with my mouse. Why or why not? Why? Because the measures are equal, the radian measures are equal. Literally, they're congruent because of this right here. The measures are equal. Is arc FD congruent to arc XY? Or if you didn't have arcs on yours, is segment FD congruent to segment XY? It doesn't matter if it's an arc or a segment. Either way, the answer is going to be no, because the circles are different sizes. Circle B is larger than circle A. So remember, the radian measure doesn't care about the size of the circle, just like degree measures don't care. What we learned about yesterday in our radian lesson is that 1 radian, 57.3 degrees, 1 radian was 1 radian in every circle that we experienced, whether the circle was tiny or large. 1 radian looked the same no matter what. But what does change when you change the size of a circle is the radius changes and the length of the arc changes. That is asking, are the arcs congruent? Congruent means same size, same shape. No, those arcs are not the same size. The distance from X to Y is more than the distance from F to D. So even though the angle is the same, the length and the actual arc itself is not congruent. Did I answer your question? All right, so now we're on to number 8. This is a little weird because it says the arc length of LM is 9. We're used to arc length having pi. That doesn't mean there's no pi in that number 9, but it just means this problem, it's not in terms of pi, and that's okay. We usually see pi, but you know what? I talked to a pre-cal teacher. Sometimes the radians are not in terms of pi. It doesn't mean it's not a radian or an arc length. It just means that they chose not to put it in terms of pi. So pi is inside somewhere inside that 9. It's factored into it. Anyways, so the distance from L to M is 9, the distance, even though we're used to seeing it as something pi. Find the following values. Write the angle measures in radians. Okay, so we want the measure of angle LCM. If we want to write that angle in radians, we learned yesterday that a radian measure is the ratio of the arc length to the radius. So if we look at the big circle, then the arc length of that circle, they gave it to us, it's 9. What's the radius of the big circle? 5 plus 4 is 9. So since the arc length equals the radius, we have a radian measure of 1. 1 radian. The answer is 1 radian. I'm not going to put my units because they already said it has to be in radians. No need to put units if the problem has already specified the answers are going to be in radians. All right, so the answer to A is 1. So this angle right here is 1 radian. 57.3 degrees, remember? 1 radian. Okay, cool. What's the measure of ACD? Well, wait a minute. Angle ACD is another way to name angle LCM. They are literally the exact same angle. So they would have the same measure, right? 1. Okay, so now I want the measure of arc AD. Now, we remember that central angles equal the measure of their arc. I'm not talking about the length of the arc, right? M stands for measure. So if the central angle is 1 radian, then the arc is 1 radian. These answers are looking quite alike, aren't they? And now, finally, it's asking for not the measure of arc AD, but the length. What is the distance from A to D? Well, if the measure of the angle, or the radian, measures 1, and we know it's L over R, we don't know the arc length. We do know the radius of that small circle. It's 4. What number would force that fraction to equal 1? What arc length? 4. Yeah. So it has to, the arc length has to equal the radius if we want the radian to be 1. All right, I'm doing number 1. I'm working backwards today. So we learned in class that a radian measure is calculated by taking the arc length and dividing it by the radius. They gave us both of those. This is just a practice in simplifying fractions, honestly. So the arc length is 3/2 pi given. The radius is 7.5 given. They're both centimeters, by the way. They're both centimeters. So the centimeters are going to cancel. Your answer should not have units, as in should not have centimeters, okay? So honestly, the rest is done in here. And you're allowed to use this, and you are encouraged to use a calculator. So I'm going to do 3/2 divided by 7.5. I get 0.2. That's an appropriate answer. I like fractions, so I'm going to be partial to fractions. I'm going to do math, enter, enter. What I did not enter in my calculator was pi, because that would take my answer from exact to approximate. So I left pi out of the equation for now. My calculator gave me 1/5. I'm going to multiply back in by pi. And honestly, since it said find the radian measure, I don't have to put units because they already dictated that the answer would be in radians. So I don't have to put degrees or radians because I already know the answer is in radians. So that's all you do. L divided by R. You leave pi out of it, you put it back on at the end. Could you put 0.2 pi? Absolutely you could. Yes. Number 5, super quick. JHI. What kind of angle is that? Hello?
Semicircle diameter.
It's a straight angle. It's a straight angle. So you've got acute angles, you've got right angles, you've got obtuse angles, and if you go all the way 180 degrees, it's a straight angle. Anyways, we know that there are 2 pi radians in a circle. So if we only wanted to go halfway around, we would just cut that in half. We talked about this in class yesterday. The radian measure of that angle is pi. Pi radians equals 180 degrees.